we're going to solve higher degree polynomial inequalities. And this time, the first one is the product of x plus 6 times x minus 3 times x minus 8 less than or equal to 0. We see this is third degree. And leading coefficient will be 1 if it were multiplied out, so greater than 0. So we know the end behavior is going to be similar to y equals x. It's going to go to positive infinity when x goes to positive infinity and negative infinity when x goes to negative infinity. We also know the x-intercepts are confined, the x-intercepts. Since we've got the factored form, they will be negative 6, 3, and 8, all with multiplicity 1. So if we put this all together, we can sketch the graph. So negative 6, positive 3, and 8. The curve is going to come from below to the smallest x-intercept, cross the x-axis, come back down through x equals 3, y equals 0, and then turn back up and continue to increase to the right of the largest x-intercept, which is 8. And so I'm not saying anything about the relative sizes of the local maximum or minimum, just where the positives and negatives are occurring. And so where is this less than or equal to 0? It occurs to the left of the first, or the smallest x-intercept, and between the second and third x-intercept. So our solution will be the interval from negative infinity to negative 6, including the negative 6 because of the less than or equal to, union the interval from 3 to 8, including both endpoints. On a number line, this is negative 6, 3, and 8. It would be negative 6 shaded circle, and to the left, closed circles at both the 3 and the 8, and a segment between them. Our second example is also cubic or third degree. It has leading coefficient greater than 0. Its end behavior will be the same. The difference is that the x-intercepts, we have 9, and we also have negative 5, where the negative 5 has multiplicity 2. And so the graph is not going to cross the x-axis at -5. So let's say this is -5 and 9. It has to come from below the smallest x-intercept, but since that has multiplicity 2, it will turn and go back below. It will never go above the x-axis at -5. Comes back down and eventually goes through the x-axis at 9 and leaves to the top right. And so we're to find where this is strictly below the x-axis because it has to be strictly negative. And we see that that occurs to the left of -5 and between -5 and 9. The endpoints are not included, so the intervals are from -infinity to -5 union -5 to 9. All open intervals. On the number line, if this is -5 and 9, there'll be open circles at both -5 and 9, but a solid ray to the left of -5 and a segment between -5 and 9. There's actually a hole in the graph because at -5 the function equals 0. So one last example. This is going to be 4th degree. So 4th degree. Again, if we multiplied it out, the leading coefficient would be greater than 0. And so it's going to be like its end behavior is going to be similar to y equals x squared. That means it comes down from the left and it leaves to the top right. And the zeros are 6, 8, and -2, where 6 has multiplicity 2. So as we go to draw this, we need to put the zeros in order. -2, 6, 8. 6 is the one with multiplicity 2, so it's not going to cross the x-axis at 6. So we come from above the smallest x-intercept, turn and reach the x-axis at 6, bounce off it, and eventually leave to the top right through the largest x-intercept. I forgot to put the y-axis in here. All right, and so this time we are looking for where is the function less than or equal to 0. So we want to know where is the graph on or below. The solution is going to be somewhat similar to the previous one. This time it will be the values between -2 and 6. And between 6 and 8. The difference is that this time we are also including the x-axis because we've got greater than or equal to. And so we actually can include 6, 0. Whereas in the previous one, we had an open circle at -5, 0 in terms of our x, our graph on the number line. But this time we have a solution which includes all the numbers in the closed interval from -2 to 8. And so on the number line, we'd have -2 and 8, and it would be closed circles at both of those and including the points, including the line between, the segment between. Up here, I didn't mean to say that -5, 0 is not in the graph of the function, just that it is not included on the number line in the solution.